final velocity minus initial velocity. So in this case, final velocity is okay guys, this is our second lesson part 2 video, motion in a straight line. So let's see. So our first subtopic is displacement time graphs. Graphs that illustrate how the displacement of a body varies with the time are called displacement time graphs. Graphs that illustrate how the displacement of a body varies with the time are called displacement time graphs. The gradient of the displacement time graph gives us velocity. The gradient of displacement time graph gives us velocity. If the gradient is same at each second, the velocity is same at each second. If the gradient is same at each second, the velocity is also same at each second. That means there is a uniform velocity. Velocity is uniform. Okay, this is our first question. So we have a table here and here the graph. So in this column there's time and in this column there's displacement. So in 0 seconds 0 meters, in 1 second 2 meters, 2 seconds 4 meters, 3 seconds 6 meters, 4 seconds 8 meters, and in 5 seconds 10 meters. So how to plot the graph? First we need to write the numbers. Displacement here 0, 2, 4, 6, 8, 10. So the time 1, 2, 3, 4 and 5 here. So now how to plot the graph? In 0 seconds 0 meters, it's here, and in 1 second 2 meters, like this, and in 2 seconds 4 meters, and in 3 seconds 6 meters, and in 4 seconds 8 meters, and in 5 seconds 10 meters. So our graph is like this, a slant line like this. So we learned that we can calculate the velocity if we get the gradient of this graph. So gradient means difference of y coordinates divided by difference of x coordinates. So difference of y coordinates 10 minus 8, we get this number and this number, and difference of x coordinates 5 divided by 4, 5 minus 4, we get this number and this number. So the answer, the velocity is 2 ms minus 1. Here 2 divided by 1. Final answer, or the velocity is 2 meters per second. So this is our second question. In 0 seconds 0 meters, in 1 second 2, 2, 4, 3, 6, 4, 8, 5, 10, and in 6 seconds also 10 meters, and also in 7 seconds 10 meters. So how to plot this graph? First we need to write the numbers. So let's write 0 to 0, so 0 here, 2, 4, 6, 8, and here 10. 10 is the maximum number here. So time 1, 2, 3, 4, 5, 6 and here 7. So now let's see how to plot this graph. In 0 seconds 0 meters, so here, and in 1 second 2, 2 seconds 4 meters, and 3 seconds 6, and 4 seconds 8, and in 5 seconds 10 meters, and also in 6 seconds 10 meters, and in 7 seconds also 10 meters. So now the graph is like this, a slant line like this, and the graph is like this. So here the object has not moved. Object is at rest. Object at rest. So let's type it. So let's get into our next question. This is our third question. There's a table. In 0 seconds 0 meters, 1, 2 seconds 4 meters, 3 seconds 6 meters, and 4 seconds also 6 meters, and 5 seconds 4 meters, 6 seconds 2 meters, and in 7 seconds 0 meters. So let's write the numbers first. Here 0, 2, 4, 6. 6 is the maximum number, and time 1, 2, 3, 4, 5, 6 and here 7. So how to plot this? Let's see. In 1 seconds 2 meters, in 0 seconds 0 meters, no, so it is there, and in 1 seconds 2 meters, and 2 seconds 4 meters, 3 seconds 6 meters, and also in 4 seconds 6 meters. So here, and in 5 seconds 4 meters, it's increasing and at rest and again decreasing. In 6 seconds 2 meters, and in 7 seconds 0 meters. So the graph is like this, a line from 0 to 6 and a straight line, and again it's decreasing. So in this time the object is at rest, and it decreased again. So in this time it came to the original position. The object has traveled to the original position again. So we solved it. This is our second subtopic, velocity time graphs. Our first subtopic is displacement time graph, and now velocity time graphs. Graphs that illustrate how the body of velocity varies with time are called velocity time graphs. In displacement time graphs, it's like this. How the body of speed varies with the time are called displacement time graph. And in velocity time graphs, how the body of velocity varies with the time are called velocity time graphs. So the gradient of the displacement time graphs gives us velocity, and this is not displacement, this is velocity time graphs. So the gradient of the velocity time graph gives us acceleration. Gradient of displacement time graphs gives us velocity. The displacement of that object can be found using the velocity time graph. The magnitude of the area under the velocity time graph equal to the displacement. We can find displacement of the object by using the velocity time graph. So the method is the magnitude of the area under the velocity time graph. We need to calculate the area under the velocity time graph to get displacement. So this is our first question related to velocity time graphs. Here in 0 seconds, 0, 1, 10, 1 in 1 second 10, and in 2 seconds 20, in 3 seconds 30, in 4 seconds also 30, in 5 seconds 20, and in 6 seconds 10, and in 7 seconds 0. So how to plot the graph? First we need to write the numbers. So here 0, velocity 10, 20, 30, 10, 20, 30. 30 is the maximum number. So times here 1, 2, 3, 4, 5, 6, 7. So the graph is like this. In 1 seconds 10 meters per second, in 2 seconds 20 meters per second, and in 3 seconds 30 meters per second, and in 4 seconds also 30 meters per second, and in 5 seconds 20 meters per second, and in 6 10 meters per second, in 7 0. So the graph is like this, a line from 0 to 30, and again a straight line, and it's decreasing again. So here there's a acceleration. Here there's acceleration, and in this place there's a constant velocity. Uniform velocity. The object has traveled from a uniform velocity here. So in the last part here, there's a deceleration. In this line an acceleration, there a uniform velocity, and here again a deceleration. So this is our final subtopic or final topic in this lesson, gravitational acceleration. All the objects on Earth are attached towards the gravity by the gravitational force. All the objects on Earth are attached towards the gravity by the gravitational force of Earth. Because of this force, free-falling objects in the atmosphere subjected to an acceleration. Because of this Earth's gravitational force, free-falling objects in the atmosphere are subjected to an acceleration. The acceleration caused due to the Earth's gravitational attraction can be named as gravitational acceleration. The acceleration caused due to the Earth's gravitational attraction is known as gravitational acceleration. So the normal gravitational acceleration is 9.8 meters per square seconds. And we can represent the gravitational acceleration as the symbol g. Normal average gravitational acceleration in sea level is 9.8 meters per second, meters per square seconds. The average calculated value at sea level is 9 meters per square second. I mentioned this. And when an object is subjected to the gravitational acceleration, its velocity increases by 9.8 meters per second at each second. If an object is subjected to the gravitational acceleration of Earth, its velocity increases by 9.8 meters per second at each second. It's like this. If this object has fallen down, its velocity increases by 9.8 meters per second at each second until this object touches the ground. So if this object took 2 seconds to touches the ground, what is the velocity of this object when it touches the ground? So in first second 9.8 meters per second, and in second 9.8 meters per second plus 9.8 meters per second. Here its velocity increases by 9.8 meters per second at each second. That means in second we need to add 9.8 meters per second to 9.8 meters per second. So the final answer is this, 19.6 meters per second. So guys, let's solve some problems related to these displacement time graphs, velocity time graphs, and gravitational acceleration. So first question, Roman number 1. Explain the difference between distance and displacement. We discussed these things in our first videos. You can check it out. Explain the difference between distance and displacement. Distance means the long paths and short paths from one point to another, or the long paths and short paths from one point to another can be named as distances. And the displacement is the shortest path, not the long or short or longest. The shortest path from one point to another point can be named as displacement. First question, Roman number 2. Find the distance traveled by the object from A to B. A to B. Find the distance, not the displacement. Not the shortest distance. So object from A to B. First he traveled from A to C and again to B. So let's calculate the total distance. Total distance 20 centimeters plus 15 meters. Sorry, it's meters, not centimeters. 20 plus 15, 35 meters. Total distance is 35 meters. Total distance is 35 meters. Find the displacement traveled by the object from A to B. So in this question we need to find the displacement. means the shortest distance from A to B. This is the shortest distance. So how to find the length of AB line? We need to apply Pythagorean relation here, like A squared plus B squared equal C squared. This is Pythagorean relation. We need to apply Pythagorean relation here to find the length of AB line. So 20 squared plus 15 squared equal, if we name this as C squared. 20 squared means 400 and 15 squared means 625. So sorry 225. C squared 625 C squared. Addition of 400 and 225 is 625. So we need to cancel this square in C. Let C equal 25 meters. Displacement is 25 meters. First question, Roman number 4. If the object has traveled from A to B via in 5 seconds without stopping, find mean speed. Mean speed means total distance divided by time. Total time. Total distance divided by total time. So we calculate the total distance as 35 meters. Yes, not centimeters, meters. So mean speed means total distance divided by total time. 5 seconds, 35 divided by 5 equal 7 and mean speed equals 7 meters per second. Our final answer is 7 meters per second. First question, Roman number 5. If the object has traveled from A to B via in 5 seconds without stopping, find mean velocity of the child. So how to find mean velocity? Mean velocity means total displacement divided by total time. Total displacement. Total displacement divided by total time. So we calculate the displacement as 25 meters by applying Pythagorean relation. So 25 meters divided by 5 seconds. The mean velocity is 5 meters per second. So our final answer is 5 meters per second. This is second question, Roman number 1. Explain the difference between scalars and vector quantities. Scalar quantities and vector quantities. So vector quantities are the physical quantities which have a magnitude and a direction. The physical quantities which have magnitude and a specific direction is known as vector quantities. And the scalar quantities are the physical quantities which have a magnitude only, no specific direction. This definition is wrong here. This is displacement definition. The physical quantities which have only a magnitude is known as scalar quantities. The physical quantities which have magnitude only is known as a scalar quantity. This is second question, Roman number 2. Classify below quantities into scalars and vectors. Distance, displacement, speed and velocity. Physical quantities are distance, displacement, speed and velocity. So let's classify. Distance is a scalar quantity because it has a magnitude but no any specific direction. Displacement is a vector quantity. It has both magnitude and direction. Speed is a scalar quantity. It hasn't a specific direction, and velocity is vector quantity. Second question, Roman number 3. The displacement time graph of an object moving along a straight line is shown in the figure below. So there are some questions related to Roman number 3. So let's see. Second question, Roman number 3, and the first question of Roman number 3. How far has the object moved after starting from the rest? How far has the object moved after starting from rest? So we need to find the area under the graph. Area under the graph is this. We need to find this area of this part. So how far has the object moved after starting from the rest? So this part. Let's calculate area of, how to find the area of a triangle. Half into base equal 4 into 4, here not 10, it's 6 into 6, 2 into here 2, we can cancel out 4, and 2 into 6, 12 meters. Object has moved after starting from rest. Object has moved 12 meters after starting from the rest. How long has it taken to travel the above distance? How long has it taken to travel above distance? Above distance means this distance. We calculate the area of this triangle, no? So means this tree from here to here. Time taken to travel from here to here is 4 seconds. See, 4 seconds. Answer for this question is 4 seconds. Find the maximum velocity of the object during that period. So we need to find the gradient to calculate the velocity. Or we can get the answer according to the equation also. Displacement is, we calculate displacement as 12 meters divided by time taken is 4 seconds. So the velocity, maximum velocity of the object during that period means during this period. During this period. So the maximum velocity is 3 meters per second. Our final answer is 3 meters per second. So what can you say about the motion during the interval from 4 seconds to 6 seconds? They are asking about this motion. This motion. They are asking about this motion. This motion. So we learned that if they are like this, there's no motion in this 4 second to 6 second. No motion. No motion. Comment on the motion during the interval from 6 seconds to 8 seconds. The object has traveled to the original position. We learned those. Object has traveled to the original position, to the starting point. Place. This is third question. If the velocity of a body varied uniformly from 10 meters per second to 25 meters per second during a time interval of 5 seconds, what was the acceleration of the body? So the equation to find acceleration is acceleration equals change of velocity divided by time. Acceleration equals change of velocity divided by time. Change of velocity means final velocity minus initial velocity. So in this case, final velocity is 25 meters per second. 25 meters per second minus initial velocity equal 10 meters per second. Divide by time is 5 seconds. So the difference of this is 15 and 5 equal 3 ms minus 2. Acceleration equal 3 meters per square seconds. Sketch the velocity time graph for the above motion and find the distance traveled during the 5 seconds. So this is the velocity time graph and in 5 seconds no. So here 25 final velocity and here initial velocity and here 5 seconds. The graph is like this. 10 from 20 by 5 seconds. From 10 meters per second to 25 meters per second by 5 seconds. So this is the graph. This is third question. The variation of the velocity of a certain object that traveled along the straight line is shown in the below graph. So this is the graph and let's see questions. What is the distance traversed at a uniform velocity? Distance traversed at a uniform velocity. So we learned that the distance traveled at uniform velocity is this. Distance traversed at a uniform velocity is this distance, and we need to find the area under the graph to find the distance. Breadth is 6 meters and the length also 6 meters. 6 meters into 6 equal 36 meters. Find the distance traversed by the object during the first 6 seconds. First 6 seconds is this. So let's find the distance. Distance means area under the graph. So it's this. Area under the graph means this. So half into 6 into 6. 3 into 6, 18 meters. The object has traveled 18 meters during the first 6 seconds. Find the deceleration during last 3 seconds. Find the deceleration during last 3 seconds. Deceleration means this thing. This is deceleration. So same equation for acceleration as well as deceleration. Change of velocity is final velocity minus initial velocity. So final velocity is 0 here. 0. Initial velocity is 6. And time is 3 seconds. We got a negative answer, so this is a deceleration, and the deceleration is 2 ms minus 1. This is final answer, 2 ms minus 1. So this is our last question, sixth question. We need to find the answer according to the knowledge of gravitational acceleration part. A fruit in a tree that detaches from the stalk takes to wait, I need to change the color of my pen. A fruit in a tree that detaches from the stalk takes 4 seconds to fall to the ground. What is its velocity when it reaches the ground? So we need to calculate the velocity when it reaches the ground. So what is the average gravitational velocity? This is average velocity of a falling object, 9.8 meters per second. So a fruit in a tree that detaches from the stalk takes 4 seconds. 4 seconds means we need to multiply 9.8 meters per second by 4 seconds. So we can get the answer as 39.2. Yeah, 39.2. 39.2 meters per square second. Sorry, velocity no. 39.2 meters per second. A fruit in a tree that detaches. This question, what is the height that it fell from? So we need to calculate the height. It's like a triangle, no, half into, we calculate the velocity as 39.2, but if we round off 9.8 meters per second, or the average velocity of a falling object, into 10, we got the answer as 10. So we write here as 40 and the base 4. 2 into 4, 80 meters. The height of that object fell from is 80 meters. Height that it fell from 80 meters. And object is projected to vertically upwards at initial velocity of 30 meters per second. Sketch the velocity time graph for the motion of the object from the time it was projected until it reaches the maximum height. So it's like this. This is the graph. Find the time taken by the object to reach its maximum height. So we know that the average velocity is 10 when we round off. So 30 meters per second divide by 10. Answer is 3 seconds. Time taken by the object is 3 seconds. So guys, thanks for watching. If you need to clarify something, leave a comment and put a like also. And don't forget to subscribe. So bye bye.